Yeah. So what is the question? VBE is 0.7 volt, as you know. Beta is equal to 100. Now you are asked to find out IB, VCC given, RB given, RC, RA. Okay. Now input KVL. You are asked to find out IB, so you can use input side. So VCC is equal to IB into RB plus VBE plus IE into RE. So this is what your this question. Now this I can write it as IE into RE as beta plus 1 into IB into RE. So that's equal to IB into RB plus VBE plus beta plus 1 into IB into RE. Now this is 20.7. So we can write this IB and IB, you can make it common. So that becomes IB into RB plus beta plus 1 into RE into beta plus 1 plus VBE. This is equal to VCC. So 20.7 minus 0.7 divided by RB plus beta plus 1 into RB. So RB plus beta plus 1 into RE is equal to what is that value? This is equal to IB. So that is equal to 20 divided by what is RB. RB is given to be 500K. 500 plus beta plus 1 into RE. Beta is 100, 101. 101 into RE into 1K. So 600. So 20 divided by 600. So that is equal to 1 by 30 milliampere. Because K will go to the other side, becoming 10 to the power minus 3. So 1 by 30 milliampere is your answer. This was your. So to the input side, KVL to the input side. So 10 volt is equal to VCC is 10 volt. So 10 volt equal to, this is 3K. RC is 3K. So 3K into IC plus this particular one is V out. Alright. So we can write VCC equal to IC into RC plus V out. So from that, what is V out? V out is equal to 10 minus 3K into IC. But we don't know what is this IC. Right. Now applying input, KVL to the input side. To the first loop, what you have? 5 volt from this V in value is given. So this is 5 volt. 5 volt is equal to IB into RB plus VBE plus IE into RE. You can write beta plus 1 into IB into RE. So IB into RB plus VBE plus beta plus 1 into IB into RE. So that is, from that we can find out IB is equal to this one, this quantity IB. What you have to do? 5 volt minus VBE, that is 5 minus 0.7, that is 4.3 divided by RB. RB value is given as 200K. 200K plus beta plus 1, that is 101 into RE. What is the value of RE? 1. So that is 101K. So 4.3 divided by 300k. Right. So IB is equal to 4.3 divided by 300. K is there, so milliampere. Now what is IC? IC is equal to beta times IB. What is beta? 100. 100 into IB is 4.3 divided by 300. So that becomes 4.3 divided by 3 milliampere. That is your IC. Now what is V out? V out is equal to 10 minus this RC is 3K. 3K into 4.3 divided by IC. 3K into IC. 4.3 divided by 3 into milliampere. K and milliampere will go. So 3 and 3 get cancelled. 10 minus 4.3 is nothing but 5.7. 5.7 volt. This V out. See, applying KVL to the input side, what we have? 15 volt. This is VCC equal to 15 volt. So 15 volt is equal to 100K. 100K into IB plus VBE plus IERE. So what is that? 15 volt minus VBE, that is 14.3. 14.3 volt is equal to IE. What is IE? That is beta plus 1 into RE. What is RE? 100 ohm. Okay. So 14.3 equal to 100 KIB. 100 KIB plus beta plus 1 into IB into RE. What is RE? 100 ohm. That you can write it as 0.1K. 0.1K. No, I just writing in terms of kilo. That's all. Okay. Now, so this is 100 KIB. This is beta plus 1. What is beta plus 1? That is again 100. So 10 IB into K you will get. So this is total 110K. So 14.3 is equal to 100 and 100. So 110K. Oh, what was that? Yeah, 14.3 volt is equal to 110 110K into IB. So what is IB equal to? 14.3 divided by 110. That is becomes milliampere. Now you want IC. IC is equal to beta 100 beta into IB, that is 100. So 143 divided by 110 or 11 milliampere. So that is 143 by 11 is nothing but 13 milliampere. Am I correct? So that is it. You got IC. IC you got as 13 milliampere. Now applying to the output, VCC equal to ICRC plus VCE plus IE into RE. Okay. Now here I can write IE as IC. IE equal to IC. So VCC equal to ICRC plus IC into RE. So IC into RC plus RE plus VCE. What you want? VCE. You want VCE. VCE equal to the maximum voltage 15 minus IC. What is IC? 13 milliampere. 13 milliampere into RC plus RE. What is RC? 900 ohm Re is 100 ohm, that is 1k. Okay, so 15 minus 13, that is 2 volt. So you are getting VCE equal to 2 volt and IC is equal to 13 milliamp. So wherever you are finding 2 volt and 13, see, look at the options, 2 volt and 13 milliampere. So your answer this one. Others no. Now if there are two options with the same value, what you have to check is for VCE. VCE is 15 volt and what is IC? That is when IB equal to 0, the maximum IC and the maximum VCE possible. This is the load line, maximum IC and maximum VCE possible. You draw a line connecting those from input output side. Why output side? You apply KVL to the output. What you get? VCC equal to ICRC plus VCE plus IE into RE. Now this I can write it as IC into RE. Okay. Now the maximum IC is when VCE equal to 0. Right. Put VCE equal to 0, you get maximum IC. Then put next one for maximum VCE. For maximum VCE, put IC equal to 0. When IC equal to 0, what you are getting is maximum VCE. Okay, for maximum VCE, put IC equal to 0. Which means IC equal to 0 means maximum VCE is always VCC. Silicon transistor. Why the silicon is given is to make you understand this voltage has about 0.7, that is built-in voltage on VBE is 0.7, VB is 9.7, RB is 300 kilo ohm, VCC is 12 volt, RC is equal to 2K. So which of the following represent the load line and Q point? Okay, this is what the question is. What you have to do is just apply input KVL and output KVL. Your answer will be ready. So just let us try to do that. Now output KVL, applying output KVL. Anywhere you can do. Let us start with output. So this is the loop that we are discussing. So this will be VCC, which is of 12. So 12 volt equal to, there is a drop across RC, so IC times RC plus this is VCE, so VCE plus no drop, so 1, 2 and the third drops. So what is asked? Q point. Q point means you need IC and VCE. So VCE equal to 12 minus IC. We don't know what is IC. Okay. So 12 minus IC. RC, what is the value of RC? 2K. So 2K kilo ohm into IC. We will leave. IC we don't know. Now what we have is input. So applying the Kirchhoff voltage law to the input side, we have VBB. VBB value is given 9.7. So 9.7 equal to IB times RB plus VBE. So that is equal to IB we don't know. RB, value of RB is given as 300K. So 300K plus VBE 0.7. So 9.7 minus 0.7, that is 9. So IB is equal to you have 9.7, that is 9 divided by 300 kilo. So this value is around so 3 by 100 milliampere. Okay, or you can write 30 microampere. So you got IB, right? Now let us see this input side, oh sorry, output side. So in the output side what we have is 12 volt is equal to VCC or 12 volt equal to ICRC plus VCE. ICRC plus VCE. Okay, so here we need a okay, so let us find the load line. How to find load line? Now first of all we want to write VCE equal to 12 minus ICRC. Now what is the maximum value of VCE? VCE maximum equal to 1 when IC equal to 0. VCE maximum is when IC equal to 0. Right? What happens when IC equal to 0? When IC is equal to 0, VCE equal to 12. So VCE 12 is the maximum. Now what happened to IC when VCE equal to 0? Now IC maximum is when VCE equal to 0. When VCE equal to 0 you get IC maximum. So what is IC maximum? IC maximum equal to IC maximum is equal to, you just put VCE equal to 0. So 12 volt equal to ICRC. RC we know. What is the value of RC? 2 kilo ohm. So 12 divided by 2 kilo ohm. So that is nothing but 6 milliampere. So IC maximum equal to 6 milliampere and VCE equal to 12. Now what is the value of the maximum VCE? Maximum VCE 12. Anywhere else 12 is there? No. So immediately you can write, and the maximum IC is equal to 6 milliampere. Now why do you know this is Q point is at this particular value? At 30 microampere, that is the value of IB, 30 microampere, you get the maximum or a stable point, that is Q point. Q point is at when IB equal to 30. What is the value? That is the Q point. This is for each value of IB corresponding IC we have written here. Okay, so the option is this one. Yeah. What is IB? IB is equal to, from the input side we know that 10.7 minus 0.7 divided by 10k. So 10 divided by 10, that is 1. 10 divided by 10, so 10 milliampere. So 1 milli ampere. Okay, this is the IB, current flowing through the base. Now from that we can immediately write IC is equal to 100 milliampere. So 100 beta times IB, 100 into 1 milliampere, that is 100 milliampere. So IC we got. Now our aim is to find out output KVL. On the output we will just apply our KVL because we know IC value. So IC, what you need? VCE unit. So 10 volt is equal to 10 volt here is equal to 2k into 100 milliampere plus VCE. Now what is the value of VCE? VCE equal to 10 minus k gets k, milliampere get cancelled, to 200. Now what is that? This is a VCE is negative, right? What do you mean by when VCE is negative? VC is at lower potential. VC is at lower potential and VE is at higher potential. Now what is the potential at VE? This potential VE, that means it is connected to ground, so it will be 0. So VC is negative. VC is negative. So this is an NPN transistor. NPN transistor. So output is on this side. So junction 2, our junction 2 is N and N reverse, sorry, N is connected to N, so this is forward, right? And here also our base, this is P connected to this voltage. P connected to P. So P connected to P, N connected to N. So this is also forward. Forward, junction 1 is also forward. Junction 2 is also forward. So forward and forward, both are F and F. Saturation. So the first one is saturation. So here beta value is 10. So input, in the input side you can find IB is equal to 5 minus 0.7 divided by RB, that is 10. So this is 4.3 divided by 10, that is equal to 0.43 milliampere. Okay. Now what is IC? IC is equal to 4.3 milliampere. Why? Because multiply by the beta. Now applying to the output, what we have? 10 volt is equal to 1k into RC. So 1 kilo ohm into IC, that is 4.3 milliampere plus VCE. So VCE equal to 10 minus 4.3, which is equal to 5.7. 5.7 volts. So this is positive, which means VC is at higher potential than at VE. Okay, so this is positive connected to positive, this is negative. So this is an NPN transistor. So N connected to positive side, that means reverse biased, right? This is this is again P connected to P. This is forward. Forward, and this is reverse. Which makes it in the active region. What is in terms of beta? Because we are very familiar with the beta terms. So IB is to IC is to IE. So this is an increasing order of the current. So IB, we will write it as IB. So what is IC? Beta IB. And what is IE? Beta plus 1 IB. So in terms of beta, we can write 1 is to beta plus 1. So this is one ratio. But this may not be asked because this is very easy. Okay. Now let us see in terms of, this is in terms of beta. Let us see in terms of alpha. Okay. So here also you can start writing IB, IC and IE. So you need in terms of alpha. What is alpha? Alpha is nothing but IC by IE. Right? IC by IE. So IC is here. Let us divide by IE. 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 So this value is equal to 1. IE by IE 1. IC by IE. What is IC by IE? IC by IE is nothing but our alpha. Right? So alpha. Now here is a problem. IB by IE. Now what you can do is find out what is IE by IB. What is IE by IB? That is nothing but IB plus IC by IB. Right? That is equal to 1 plus IC by IB. Okay, here also we have one problem. We can write IB in terms of no need. So IB equal to IE minus IC. You can write IB in terms of IC and IE. So IE minus IC divided by IE. So please leave this, don't need not write. So IC minus IE minus IC by IE. So that is 1 minus IC by IE. What is IC by IE? IC by IE is nothing but alpha. So 1 minus alpha. So 1 minus alpha is to 1. This is the ratio, increasing order. Now again, in terms of gamma. In terms of gamma means, what is gamma? Gamma is nothing but IE divided by IC or IB. Gamma is in common collector, right? So common collector means it will not come, IB will come. Common collector. IE by IB. So here also you can start writing IB, IC and IE divided by IB divided by IB divided by IB. What you have to do, you have to just write IE in terms of a different term. So IE by IB, this is equal to gamma, and IC by IB, you just have to write in terms of IE minus IB. So gamma minus 1, right? Gamma minus 1, and this value is 1. So 1 is to gamma minus 1 is to gamma. See, potential at C is given. This collector potential is given. So VC is equal to 9 volt. VCC is also given 15. So this much drop is 9 volt because there is no drop across collector. So 9 volt, 15 volt. So what will be the current through this C or this particular this thing? So this is, let me write this as I. So I, which is equal to IC plus IB, and what is that equal to? IE. Now what is IE? I is equal to this drop, voltage drop across these 2 points, divided by RC, right? So I is equal to IC plus IB, and you can write 15 minus 9 divided by RC. That is nothing but RC value you will get. So 15 minus 9, that is equal to 6, divided by IC, or you can write I. Alright, RC value 6 by I, or if you want you can write, no need, you can put I only. Now what is RB? In order to find RB, you have to go through the input, right? This is the input. Now what is the voltage at this point? 9 volt. 9 volt is equal to, it's actually not input, this loop you can consider from this point to this point. Why? Because there is no voltage drop across these points, so up to here you can consider, right? So what is RB? You can write 9 volt into IB times RB, plus VBE you can put it as 0.7. So 8.3 equal to IB times RB. So what is RB? RB equal to 8.3 divided by IB. Now what you want? RB by RC. RB you got, RC you got. Now RB divided by RC is equal to 8.3 divided by IB divided by RC, 6 divided by what is I? I is equal to IE, which is equal to beta plus 1 IB. Beta value is given 76. Beta plus 1 is 75. Beta plus 1 is 76 times IB. So 76 times IB. So IB gets cancelled. So 8.3 into 76 divided by 6. This value will be around 105. So transistor in the given circuit is in active region. Why it is given active region? Just to say it is first one is forward and another is reverse bias. Okay. Now input KVL. So 5 volt minus 0.7 divided by 2K will be your IB. So what is IB? 4.3 divided by 2K. Okay. So this is your IB. Now what is IC? Beta times IB. So what is beta? 100. So 100 into 4.3 divided by 2k. This is your IC. Now what you want? In the output side VC saturation is also given 0.2 volt. Okay, so just apply the KVL to the output. So 5 volt is equal to ICRC plus 0.2. So 5 volt is equal to IC into RC. IC is 100 into 4.3 divided by 2k into RC value. RC you don't know, so RC we will keep it as it is, plus 0.2 plus 0.2. So 5 minus 0.2, what is that? 4.8 is equal to 4.8 into 2k divided by 100 into 4.3. Okay, that is what is your RC is. So what is that value? 9.8 104. Okay, all right. So this is 9.6k divided by 430. So you have, first of all, let us see output. So this voltage VCE is given to be 5 volt. So there will be a drop here also, but that is nothing but IE into RE. So here also you have a drop which is nothing but IE. Whatever current is flowing to this, it will come to this also. So IE into RE plus, so IE into 10 kilo ohm and a drop which is VCE. So we can write 20 volt is equal to 10k into IE plus VCE, that is 5 volt, plus let us write this as 0.2k, 0.2k into IE, right? So 15 is equal to 10k plus 0.2k into IE. So IE into 10.2k. So what is that? IE is nothing but 15 divided by 10.2k. So that you will get around 1.4 milliampere. So IE is given. Okay, that you can take approximately as IC, or if you want IB, that also can be found. Okay, if you want IB, that also can be found. Right, so IC you can write approximately equal to 1.4. Now what you want? IB. IB is equal to IC by beta. Beta is not, that is IC, that is 1.4 milliampere by 50, which is equal to 1.4, 2.8 by 100, that means equal to 28 microampere. So IB value also you got, IC value we got. Okay, this is a maximum IC. Okay, this is a maximum IB. Actually this is not IE, this is IC. Sorry, not IC, this is actually IE, the maximum current. But we are approximating it to IE and we are getting IB value. Now what we have to do is, you know what is this drop. So IB value what we got is 28 microampere. IB equal to 28 microampere and IC value is nothing but 1.4 milliampere. Now at this point you know what is the voltage drop. So let us write that once again, the input side. So input side we can write 20 volt is equal to IE into 10k plus IE into 10k plus IB. So RB, this is what we want, RB value. RB into IB is nothing but 28 microampere plus VBE 0.7 plus 0.2k into IE, right? So 20 volt is equal to IE into 10.2 plus RB into 28 microampere, and 0.7 volt also you can write. So 19.3 equal to, now IE value you can write as 1.4. So 1.4 into 10.2 plus RB into 28 microampere. Now 14 into 10.2, sorry, yeah, 1.4 into 10.2 can write around 15 or 14.5 something. So that value can write 15. So 4 point, sorry, this is 19.3. okay, why 0.7, 19.3 minus 15, that you can write 4.3 equal to RB into 28 microampere. So RB is equal to 4.3 divided by 28 microampere. So this value is around 150 or 140, you can write 140 kilo ohm. So this is it.